Assalamualaikum warahmatullahi wabarakatuh. Welcome. Now I want to explain topic 4.6, which is the integrating trigonometric function. So these are the derivative of trigonometric function. So in this topic, it is basically to find the basic formulas of trigonometric integrals. So that's mean when we integrate cosecant x cot x dx, we will get negative cosecant x plus c. In this topic, there are 4 subtopics, which is number 1, powers of sine and cosine. Okay, for example, we want to integrate sine cube 3 theta d theta. Number 2, the product of sine and cosine. Product. Okay, sine and cosine. Number 3, powers of secant and tangent. Number 4 is the product of secant, tangent. The product, okay, of secant, tangent. Let's look number 1, which is the integrating powers of sine and cosine. In the workbook, there are 2 methods to find the integral of powers of sine and cosine, which is using identity and also using the reduction formula. But please ignore the reduction formula because this is not in the syllabus. So we are going to use using identities only. Alright. So integrating powers of sine and cosine. Okay, when we look at the power, okay, for sine, for example, when the power is even, okay, for example, sine power 4x, okay, we use the double angle formula. Okay, for example, sine squared x, okay, this formula is derived from double angle formula in MAT02. Sine squared x is equal to 1 minus cos 2 theta over 2. If the power is odd, then we need to split it into even and odd. For odd, let u is equal to cos x and then differentiate u with respect to x, we get negative sine x. Okay, for the even part, use the sine squared x is equal to 1 minus cos squared x. This is identities formula. Okay, for cos, when the n is even, we use the double angle formula, while when n is odd, we split it into 2, which is even and odd part. The odd, let u is equal to sine x and differentiate with respect to x. Okay, the even part, we use the identities formula. So now I want to discuss example for 4.6, integrating trigonometric function, which consists of integrating powers of sine and cosine. So in the workbook, it is at page 238. Alright. So number 2, the integral of sine cube 2 theta d theta. Now, when we see the previous note, when integrating powers of sine, if the n is odd, okay, we need to split it into 2, which is split into even power and also odd power. Okay, so now sine cube 2 theta, we split it into even power multiply odd power. Okay, next, for odd power, we let it as u is equal cos theta. So now the odd power is sine 2 theta. We let u is equal to cos theta. Okay, if it is sine odd, let u is equal cos theta. Differentiate cos theta, we get negative sine 2 theta multiply 2 because this is a derivative of composite function. Okay, so simplify, we get negative 2 sine 2 theta. From the given question, okay, sine squared 2 theta multiply sine 2 theta. Okay, d theta here, Okay, d theta is equal to du over negative 2 sine 2 theta. Here, substitute. And then simplify, common factor, and then we get sine squared 2 theta du over negative 2. Okay, negative 1 over 2 is constant, so take out negative 1 over 2. So now we have the integral of sine squared 2 theta. So sine squared 2 theta is even here. Okay, even. So when it is even, we use the identities formula. So we know sine squared theta plus cos squared theta is equal to 1. Therefore, sine squared theta or sine squared 2 theta is equal to 1 minus cos squared 2 theta. Right? So, as we know, cos 2 theta is equal to u. So, cos 2 theta is equal to u. So, now it is become u squared. So, make sure that all in terms of u. Integrate 1 minus u squared du. So we get this one. Okay, don't forget to plus c because this is indefinite integral. Next, back substitution u where u is cos 2 theta. So this is the final answer.